And so to start, I gave a workshop a few months ago doing edge machine learning, and it was with the TinyML, the little Arduino boards that you can get with a little camera, and we had it identify rock, paper, scissors, which was fun.
One of these?
No, is that the ESP32S30?
Yes.
Yes. So we actually did it on the Arduino Nano 33 BLE Sense, because that's what I happen to have like 30 of.
Yeah.
But that's like my favorite go-to right now.
Can we put ML on this?
Oh yeah, is that the S3 or the C3?
S3.
It's yes. Oh yeah. I mean, it'll work on both. It's just a question of the power. The S3 actually has like certain. It's got like an accelerator in it where you can do some sped up neural network stuff. I couldn't get like full object detection working on it because those models are usually too big. I know, but you can do like edge impulses, FOMO, and there's some smaller stuff you can do like image classification. It'll do the hand gesture thing, no problem. Yeah, image classification, no problem. But
not object detection.
I couldn't get object detection. I tried. I was like compiling what's the YOLO V5 Tiny or whatever. I was like compiling that, it still won't fit. There's not enough, there's really not, the problem is not enough RAM and flash available to get one of those on there. I tried. I was at this conference, the SuperCon conference, sitting in the back trying to get YOLO going on that thing. It's just not working.
SuperCon this year?
This was last year. This was 2023. It's always in November.
Yeah.
If you're able to
that's
go.
what I meant, like the recent one.
Yeah. Oh, sorry. Yes. This was actually the recent one. If you haven't been, SuperCon is amazing. You just sit around and tinker all day, and there's talks and such. Yeah. It's my favorite. It's my favorite. I try to go every year.
Oh, cool.
Would an older version be, or would a newer version be more likely to be able to be compiled?
No,
Think of like
newer.
Newer would be
because they, especially with the S3s, they've started adding all these like acceleration in hardware. So that's where I was real hoping I could get like YOLO Tiny on there.
Yeah.
And just no dice. I was able to get some object detection on a Google Coral Micro. It's the best I've been able to do for a microcontroller.
Right.
My hope is that we're going to get ARM, the ARM Cortex M33, or sorry, not the M33, the good lord, the U55, the U65, and the U85. Those are like accelerator co-processors that are now getting part of these chips. So like the Aleph chips you can get. I mean, they're like this big with like a Cortex M7 in there and a U55. And I saw it running full object detection at like 10 frames a second.
Wow.
And I mean, the Google Coral Micro is awful to work with. I don't recommend it.
Oh,
But the new chips that are coming out, I think Renesas announced it, and some others. We're starting to finally get it. We'll get an Arduino very, very soon, but we'll be able to do object detection on these very, very soon.
Wow, cool. Okay.
Yeah.
That'd be very interesting.
Yeah. Oh yeah. I'm super.
But...
I'm super excited about that. Because I had a whole project where I did the XRP, that new robotics platform. Has anybody tinkered with that or seen that?
XRP?
Yeah, it's the SparkFun did it with a collaboration with like First Robotics. It's actually a pretty slick little platform. Yeah. And so DigiKey sent me one, and I was like, oh, they have like a distance sensor. I'm like, no, throw that away. Let's put object detection on it. And I did it with the Coral Micro, which was freaking awful.
Oh, really? Okay.
But that video will be coming out soon.
Messing around with it. Micro, the Coral.
What's that?
I was thinking of checking out the Coral.
Check it out if you want. I mean, I spent a month getting it to do object detection. It was like out of the box, it'll run its like thing, but you're like, how do I train my own object detection model? And I spent like a month trying to get things like all version matching line up. It was awful. I have a video coming out. I have a GitHub repo if you're interested. It'll work for you, but it is rough. Yeah. So that's why I'm excited for these newer systems where like, oh, it'll like plug into Edge Impulse, or it'll plug into like, it'll just take a model more easily. So that's what I'm really excited about. Cool. So we'll dive into specifics. Yeah,
we've already started.
No, this is absolutely perfect. Yeah, I'm excited. This is a small crew, so feel free to ask questions. And if your slide gets boring, be like, so does everybody know edge machine learning? No. Okay, cool. Yeah, I'll go through some of these slides to give people an idea. And then I've got like fun projects that I've done in the past. I couldn't bring any demos with me because I've either cannibalized them for parts or the pendulum broke in transit after SuperCon. And I kind of glued it, but I was like, I don't know. I pulled the S3. So if you wanted to see the S3, but you got one already. Yeah, it's the same. It's the exact board I use, just no camera. Let's see. Okay, I'm gonna bring up this. Hooray! That does seem to be working. Sweet. Okay, so for anybody who doesn't know, my name is Sean Hemel. I'm a developer relations engineer with a company called Edge Impulse. This is a startup. We are completely remote. And I do developer relations, which means going around giving talks, teaching people how to use this, building fun projects, trying to use Edge Impulse where possible. And Edge Impulse is set up to help people train and deploy machine learning models, which I'll give you a broad overview of what that looks like here, to very small devices. And that's generally, a lot of it is targeted at your microcontrollers, things like your ESP32, your Arduinos, but also single board computers. Yep, also single board computers like your Raspberry Pi or your NVIDIA Jetson Orin series. We've got a lot of industrial customers who are excited about that because now we can do object detection at 30, 50, 60 frames a second, which is super fast because it's a mini GPU, right? It's a mini graphics card. I lost the chat window. So if people chat stuff in there, just
Yeah,
let
we'll
me
see
know.
over here.
Perfect, thanks. So, quick overview of what is AI versus ML. And it's kind of taken me a bit to wrap my head around this, but these are my absolute favorite definitions. Good, y'all can see it because I can't. The best way to view this is machine learning is a subset of artificial intelligence. And I really like John McCarthy's definition of AI, considering he's kind of the person who coined it. So he coined the term back in 1956. They did this whole like summer of AI conference, and like this was the founding of what is considered AI. So he's considered generally like the founding father of AI. So he named it AI, and then he gave a much better definition in 2007 when people asked him, well, what does AI mean, right? Because it's kind of this broad concept. I had some coworkers who went to, y'all are familiar with CES in Las Vegas every year? Yeah, they went to CES. And they were like, everything is AI, everything is AI. And it's just like, because it's such a broad definition, like these companies will be like, it's a thermostat, it's got a microcontroller in it, it's AI.
Yeah.
It's AI now.
So frustrating.
I know, it's just the hype, right? It's like, it'll sell it because it's AI. So when you look at his super broad definition here, it says, he says AI is the science and engineering of making intelligent machines, where intelligence is the computational part of the ability to achieve goals in the world. And that's like, well, what is intelligence? So he goes ahead and defines what he believes intelligence to be. So the idea of achieving goals in the world, my thermostat, right? I don't have a Nest. I don't have like super slick Nest or anything. I've got the thing that says, if it's below 65 degrees, turn on the heater, right? According to this definition, that's AI. So that's why all these companies can go ahead and slap AI on their devices and not be lying, but it's real sketchy. Most of the time when people are talking about AI, they're usually referring to this subset known as machine learning, which has a much more specific definition. The term machine learning comes from Arthur Samuel's paper in 1959. Arthur Samuel is famous for creating the first device that can play checkers, that learns over time. It played itself in checkers and eventually got better at doing the game of checkers and beat him because, well, he said he was a terrible checkers player and he wanted to make a machine to do it to play his friends because he really sucked at checkers. So he wrote this paper, he coined the term machine learning, but I actually really like Tom Mitchell's definition from the 1997 textbook. And this is like, very technical computer sciencey, but it gives an idea of what machine learning is and how it's a little deeper than artificial intelligence. He says a computer program is said to learn from experiences or experience E with respect to some class of tasks T and performance measure P if its performance in tasks in T as measured by P improves with experience E. In other words, can the computer program learn over time? Can it get better? That's all we care about. Does it learn from past experiences? So that's kind of why we say machine learning is a subset of AI. And then there's this thing called deep learning that you've probably heard about. All it means is we're using more complex stuff from machine learning. That's really all that means, usually specifically around using complex neural networks. So you hear like deep neural networks. That's usually what deep learning actually refers to. And that came from Rena Dekter's paper, which was biomedical, I think. Correct me if I'm wrong on that one, from 1986. So hopefully that gives you a very broad history of AI. I can push buttons. So in traditional programming, we usually set the rules. The humans design the rules, known as an algorithm. We say, hey, my thermostat goes, if it's below 65 degrees, or whatever the user sets it as, let's turn on the heater. Real simple. We design the rules, we have an idea of what it should be, and the computer program follows that and gives us those results. Machine learning is a little bit different. We don't know the rules. The rules might be a little too complicated. Hey, am I looking at a cat or a dog? That's really hard to come up like, well, which pixels and which colors, right? That's really difficult to do. So we create this thing called machine learning to come up with the rules for us. We say, here's a collection of pixels. I'm going to tell you that this is a cat, and I'm going to shove this into this algorithm. And then here's another picture, and that's a dog. I'm going to shove this in. And you do that 10,000 pictures with the labels, and it comes up with the rules for you. So that's where machine learning comes from. It's actually learning these rules and creating these. We're not developing themselves. We are developing the algorithms for the machine learning, but not the end rules. Those rules then get deployed into something to perform something known as inference. This is where new data comes in, where you've got, say, an unknown picture. You say, hey, I've developed the rules. From all this data I've given you, you can tell me cat versus dog. Here's a picture. It's never seen this picture before. So it's going to make a prediction, and that's known as performing inference. It's going to infer something from those collection of pixels to say, hey, is this cat or is this a dog? So hopefully that gives you an idea of like why machine learning is a little bit different. There's kind of three main categories that things fall into. Has anybody done Excel and done like fit line in Excel? Yes, you've done machine learning. Congratulations. Yeah, regression is now part of machine learning because it fits into this idea of we're going to generate a model, even if it's AX plus B equals Y, like we're going to fit a line to that. That's now machine learning because it's, yeah, but there's much more there's many more complicated algorithms out there that you can use for regression up to like fully complex neural networks. And then we have things like classification where we say, hey, here's a picture of a cat, here's a picture of a dog. We assign the labels, we create the ground truth, and the model, the mathematical model, determines how to look at those pictures and eventually come with an idea of how do I determine if something's cat or if something's dog. We also have things called unsupervised learning, and this is usually things like clustering. You'll see this used for things like anomaly detection, spam filtering, I can't remember where recommendation systems fall in. That either regression or unsupervised. Can't quite remember. But this is also useful in like marketing, where I've got people who might be using my platform, my tool, my database, and I want to figure out, oh, based on their usage statistics, what kind of user are they, or how many different types of users. So we use these things called clustering algorithms to do that. We also have this third one called reinforcement learning, and that's where, have y'all seen like it was like IBM where they played chess against Kasparov. I believe they use reinforcement learning for that. There was also Google made this really famous when they had AlphaGo, and they played the world champions in Go, and they got better and eventually beat the world champions in Go and came up with all these like really weird moves, and it like changed the game of Go. Like the strategies, it's super wild. There's a whole like hour-long video if you're interested. It's super wild how Google did this and created this reinforcement learning algorithm. And it's really, the video is really well done. So I recommend checking it out. Or the other famous one was where they like played StarCraft and they like beat the best StarCraft players. So that's all reinforcement learning. I did something with reinforcement learning, I'll show you later, where I try to get it to work with robotics. And that's been a lot of fun. It's stuff like Boston Dynamics doing, but since I'm not Boston Dynamics, it's like to the best of my ability. One man Boston Dynamics show, right? But it's like, how can I make it more like a maker thing? Right?
Yeah, how can anybody make that?
Yeah, so
that's buying that $30,000.
Exactly. Well, and what they want to do is they want to sell you the dog that's already been trained, right? Or maybe it does some learning on the back end, but they're trying to set up those systems where it's like you buy the dog and it's like it does the warehouse stuff for you. That's where they're going with that. I want to be like, oh, you buy the like $200, it was like the Biddle. Have you seen these? They're like little quadruped cat looking things. I know. There was a group I gave a workshop to out in Harvard that was playing with one, and they were trying to use reinforcement learning on it. I want to get one. And like my goal is to get one of those, or like put together any arbitrary Lego brick or like a 3D printed thing and be like push button and you learn to walk overnight. Like that would be so good. We're nowhere near that, but like that's kind of a goal. So examples of machine learning that you've probably seen before, things like recommendation systems, who uses like Netflix or Amazon or right, any of those. Anytime they give you like, oh, we recommend this next movie, or we recommend these products to go along with your 3D printer. That's all using machine learning. It's using what's called a recommendation system or a recommender. Spam and fraud detection. Hey, is this credit card swipe? Was that a fraudulent transaction? We're gonna send you an automated note saying, hey, we think this is fraudulent. It's all using things like clustering, anomaly detection to determine if something's wrong. And then of course, we're all familiar with ChatGPT and DALL-E and the generative, that this is the big hype right now, because ChatGPT is absolutely amazing. Technologically speaking, ChatGPT is amazing. There's a lot of concerns about what it means for artists in the world. If y'all have been keeping up with the news, there's a lot of concern what it means for like screenwriters, for programmers, right? The programmers are all excited because they have these tools, and I'm like, junior programmers, your jobs are like on the line right now. Because I fired up Google or what is it, GitHub Copilot, not Google, GitHub Copilot. Have you all tinkered with Copilot or
Yeah.
ChatGPT?
Yeah.
Yeah, a little, okay. ChatGPT, especially the fourth version, is wonderful. Like, oh, can you write me this function? And it's really good at doing it. It's not really good at like, can you create a whole program? That's where it kind of fails, but it's really good.
Algorithm for one particular thing.
With that,
Some algorithm for one particular thing.
yeah, if you give it like a really good bounded problem, it's actually pretty good. Now, if you watch some videos where like expert programmers, they will be like, here's where it failed, or it didn't catch this bug. Because remember, it's trained on what the large population of people think and have written about. So it misses like divide by zero bugs that might be in there. So just, I always recommend, don't just straight trust it, at least for right now. I believe we're gonna get to the point where things like ChatGPT will be able to code better than like 98% of people. And there's only gonna be a few experts who do it better. And I look at this from a perspective of like, y'all have a basic understanding of like how compilers work, where you write like something like English and then it takes it and moves it to machine code. Most of the time, especially if you deal with embedded systems, you're trying to write some funky thing in C and you're like, oh, I'm gonna try to optimize this with assembly. And the general popular thing that people like to say is you're probably not gonna beat the compiler. Just write your thing in C and let the compiler deal with it because you're probably not gonna optimize it better unless you really understand the hardware and the architecture that goes behind it. Then maybe you'll beat the compiler. But most of these days, we just trust the compiler to do it for us. I think but personally, I believe in like 5 years, we're just going to be able to be like, write this function for me, and ChatGPT is going to give me something better than I can probably do. That's where we're getting at. And it's going to be able to like beat most junior programmers, no problem. So yes, I think junior programmers should be scared, but you should still always check it. Always check the output, right? Don't take it at face value, at least for the time being. So, quick overview. I'm going to give you the industrial, professional, business view of cloud versus edge computing and edge AI, and then I'll show you some examples of where it's being used today to like solve problems in industry, and then we'll talk about like all the really cool, fun, creative projects that you can do with it. So when I talk about edge AI, edge computing, edge is basically everything the cloud is not. So I'm assuming y'all are familiar with cloud, like Google Drive, Google Docs, anytime. Well, like what else is cloud? Any Dropbox, Azure. Yeah, anytime you're doing computational stuff on a server somewhere, not on your computer, essentially. Usually across the internet. Yep. Yeah, those are all good. Yeah, GitHub. GitHub doesn't do much processing unless you talk about like the GitHub.io side, or you start running the like what are the actions, the GitHub actions where you're like, oh, I checked something in, automatically check my code, that kind of stuff.
Integrated with Travis or something like that.
Yeah, Travis, yeah, exactly. So all those like CI/CD tools, all that's cloud compute, exactly. But then we talk about the edge, which is everything else. It's called the edge from the perspective of the internet service providers and those big companies who run those big servers that make up the bulk of the internet, and the backbone. Something like a local router, like if I set up a rack here with my own server, that's still considered edge because it's outside the control of big internet stuff. My laptop, my phone, little IoT sensors, all of that is considered edge. And then edge computing is, instead of just saying, oh, I'm going to capture data and send it to Azure, I'm going to capture data and I'm going to perform processing on the device itself. And that gives us a number of benefits, especially when we can start doing AI on those devices, right? Your phone's already doing a crap load of AI. Right? Hey Siri, fall detection, my watch for like sleep, all this is AI and a lot of it's being done on the phone. So here's kind of your normal view of what like doing AI processing from like an IoT sensor. So normally you might say like, oh, I've got my ESP32, I'm going to make a weather station outside, it's going to collect a bunch of data, and then it's going to start sending this to these servers, and then the servers are going to do the rules model over here is machine learning on these big servers, right? Fine, that's great. It means I can have a really small board. I don't need all the processing power in ESP32. I can use an ESP8266 and just do capture data send. Great. So there's an issue with this, and that is, first of all, if you're familiar with, if you ever try to run one of those things on battery, you'll know that transmission is super power hungry. Transmission loves to eat your battery. So That becomes a problem both from if I want this to last a while on battery, as well as if I'm trying to plug it to the wall and I'm trying to be energy conscious. Transmission is expensive, it always is. The next thing is your bandwidth, okay? Sending some weather data, not a big deal, right? What is that, a couple of bytes every now and then? Think about if you put that camera up in a room right now and I want to do person counting. Now I have to stream raw video all the time. What if I want to put this in every room in this building? How much, yeah, you start eating bandwidth pretty quickly, right? If you ever use like BitTorrent and like everyone in your household goes, why is my network not working? Because you're using BitTorrent and you're just chewing all your bandwidth. That starts to happen. So you start having a lot of bandwidth issues, especially for like streaming audio, streaming data, excuse me, streaming video all the time. And then there's the results lag. You have latency, right? It might take a few hundred milliseconds or a couple of seconds to send it to a server and then wait for the result. You know, for like weather stuff, that's fine. Post it on a dashboard, predict if there's snow coming, great. But when you start talking about like, oh, I have to process, a machine is running and I need to shut down the whole production line in an industrial setting because I detected an anomaly, 100 milliseconds might be catastrophic. So if I can do local processing and guarantee those results in less than a few milliseconds, now we're talking. Now we can start doing some real like predictive maintenance, anomaly detection, that kind of thing on the edge. This is an example like what happens if I cut this connection and I start running the rules on these devices themselves rather than waiting for that internet connection and those latencies. So I like this BLERP, the BLERP acronym, because Edge AI it saves you on bandwidth, it reduces your latency, usually more energy efficient. If you need like big AI or big ML, sometimes that's more efficient because you can batch process a lot of things. But if you're just trying to run like a small thing, there's a lot of overhead of transmitting, going through your router hops, getting to your server. The server's running probably an operating system with a Docker container that's running another operating system that's now doing like multi-threading or multi-processing. So you have all these layers, which is chewing through a lot of power. There's also reliability from the sense of what happens if I lose internet connection or my internet connection is very spotty. Things like self-driving cars, that's a problem, right? If you lose internet connection, and what happens now? So a lot of that processing is done on the cars themselves, with the exception of like I need to update my model or something, or I'm collecting data, that kind of thing. But these are South Korean self-driving buses that I think last year we're experimenting with. Wish I knew more about the history of those. And then there's also privacy. Don't look at the Alexa for privacy because that's been an issue, right? People murdering somebody, the Alexa capture that. You're like, I was like, is the Alexa listening to me?
Yeah.
So the idea is if I run it locally, I don't necessarily need to send all that raw data. So if we've got cameras up in the corner to say, hey, there's 5 people in this room, let's not pump as much heat in here, or let's give them more AC depending on the temperature because I know there's more people in here. Well, if that's all going across the network, I might be concerned that, oh, now every camera, every room knows where I am, as opposed to, oh, I can guarantee that camera is not sending that raw data. It's just capturing data and saying there's 6 people in this room or 5 people in this room. So I can guarantee privacy from that respect, which is really good, right? I mean, not, you know, we can't guarantee somebody's not going to hack into your ESP32 and like pull out the images, but I can guarantee that data is not being offloaded somewhere, which is really nice. The Alexas, or excuse me, your Echo devices, your smart speaker, these are actually a little good example of a combination of Edge ML and Big ML because it's doing keyword spotting. All the processing to say, hey, Alexa, or hey Siri, that's all being done locally on the device because it needs to respond immediately, right? That's solving the latency problem. So the model is actually on the device, it's doing that processing, so it's listening to you, but it's just looking for that one word. It's a very narrow use case. Once it hears that keyword or key phrase, then it opens up the speakers and opens up a pipe to the Amazon servers, and it starts streaming that audio where big ML happens, where it does something called intent analysis, where it tries to figure out what you're asking for before generating a response to come back to you. Sweet, any questions on Edge AI so far? Is this all making sense and like y'all haven't tinkered with it? Okay.
Yeah.
This is just more examples of it. The Aura Ring, your smartwatch, things like health and wearables, monitoring your fitness levels. Industrial, I talked about things like predictive maintenance. This is a device that Edge Impulse made as a reference design where you can just take it and strap it to your machine and you can say like, learn what my machine does by listening to audio, by looking at vibration data. There's also a current sensor you can put it. So it looks at all these things and develops a model for, hey, is my lathe, is my CNC machine, is my production line, is my conveyor belt operating correctly. I mean, there's things like people strapping devices like this or developing solutions for things like escalators, elevators, to say, hey, do these things need maintenance? Is something sound off? Did anybody ever listen to like NPR Car Talk?
Yes.
So the guys, they'd be like, is it more of a ding 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 ding, or is it more of a da 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 da, right? And they can know by the sound, and they're like, this is what's wrong with your engine. So we're doing this with these edge devices. We're basically having like car talk guys in these little devices, and like, this is your device sounds wrong, and either it's wrong and I don't know what it is, or like, hey, your pulley's off or something like that. And now we can send these statistics back because we're doing it all on these devices. Infrastructure, this is a RAM 1, this is installed in power grids or on these like big transmission lines that say it just monitors the leakage current going from the power lines down to the ground. And it says like, oh, something's off, there's too much, there's too little, there's too many spikes or something. And it's using anomaly detection to figure out, is there something wrong? And do we need to fly somebody out into the middle of the Amazon where these things run and fix them? And then of course the Nest, we all know that uses some AI. So, okay, any questions on the industrial use cases and why there's like, hype and money to be made around some of these things right now? So it's solving these unique problems in the industrial space. So now we get to the fun problem. So I'm assuming everyone here is like part of the like Atlas Creative Technology program. Yes, this is the fun stuff. Hopefully this will give you some ideas. This was my hope. Like, show you the industrial stuff, get the boring stuff out of the way. Now we can talk about the really fun projects. Yeah, because this is where I like to play as well. So this is Benjamin Cabe. At the time, he was a DevRel engineer for Microsoft. He's now working for the Zephyr project. He made this artificial nose using AI. What's that?
I think there's a question.
Oh, we got a question.
About the recording.
Someone wants the recording.
Cool.
Yes.
Yes.
Once it's ready.
Uh-oh, I'm on
It's
camera.
the website.
Okay.
Thank you.
I can also share these slides too. Hopefully they can help give some ideas. Yeah, absolutely. So he created this thing, this artificial nose. He used, I think, 4 different gas sensors looking for like volatile organic compounds, ethanol, carbon monoxide. And he would put it over different things, usually food or drink. So like whiskey or coffee or freshly baked bread or rice, right? Anything that you can smell. And like as a human, we can go, oh, I can identify this smell. And so he's trying to create a classification system. And I say try, he actually did. For identifying things like coffee and bread and rice and so on. And it was using these gas sensors, and it would take the data from the gas sensors and it would train a neural network to say, oh, this data coming in, that's rice. This data coming in, that's bread. And so he deployed it to the Seed Studio Weo terminal, and it would give you an indication of what that is. So I wanted to take this a step further. I took his idea and I wanted to build upon it because I like the idea of like, let's put AI with food because that's a lot of fun. How many people have a toaster like this at home? Like really, really basic. You're a toaster oven person, aren't you?
Yeah, we don't have a toaster.
You're toaster oven person, I know.
I don't have a fancy one, I don't have a basic one.
Oh yeah, this is the like $20 Black & Decker from like Bed Bath & Beyond. But like even the like $50, $60 ones, they all use this stupid arbitrary timer. Like it's literally just a timer. You just move it. It's not a temperature sensor. It's just like how long does the toast stay down for, and it doesn't control like anything with the coils. So it is the stupidest thing because as soon as you're like, I have it set for the bread I like, and the second you go to put a frozen bagel in there,
It's completely different.
it's all off.
It's on fire.
Yeah, right. You know what I'm talking about. It's completely ridiculous. And so I was like, oh my goodness, like there's got to be a better way. And like I just want to throw AI at it for fun, just because I could. So here was the idea: is I'm going to take the gas sensors. I started with the same ones that Benjamin used in his project, but I also bought like ethanol, CO2, and a bunch of others. I'm like, just throw all the gas sensors at it and try to collect a bunch of data to figure out when the toast was getting to that perfect done stage. And I would train the machine learning model, and I used regression. The idea was to get to the point of saying when I tried to figure out the number of seconds until the toast was burnt. And then I could work backwards from there and say, okay, if I know the toast is burnt at 0 seconds, then like 30 or 40 seconds before that happens, let's stop the toasting process. And that should give me pretty close. And so that's what I did. I trained a machine learning model. I put it in a microcontroller. I used the Weo terminal because it made for a really nice video where I could show the number of seconds remaining. I hacked a toaster, and this is kind of the idea is it gave me that measurement of time until burnt. And then I would try to stop it before it got to burnt or catch fire, because that would be really unfortunate. And of course, I trained this with a whole bunch of toast. So this is the collection of gas sensors. You know, this is not a, like, I don't 3D print many things. And so I don't make my builds look very nice. So it's just a collection of boards and cables everywhere. I have a little fan to make sure it's sucking up the gases and blowing it over the sensors in a consistent manner. I think I have like 10 different sensors on there. So this collection here, these 4 sensors were the ones that Benjamin Cabe originally used for his. I just threw like a different VOC sensor. I think this is ethanol over here, and there was like temperature and humidity. I threw it all. And of course I burnt a lot of toast. My girlfriend was like, I'm so glad I was not home when you were doing this, because the whole house smelled like burnt toast for like 3 days. It was awful. But I ended up with a bunch of really good data. So if you can see the blue, and what I did was I had a button. And so I was burning the toast. I had a button, and I would say, okay, I started toasting. So up until the point of it turning green, it was not on. And so I hit a button, and it would classify it as I'm now toasting. And so that's the green. You can see all, like, especially like your temperature's going up, your humidity's going down. It's, you know, getting a little drier. Your pressure hopefully doesn't do anything. That would be weird. Carbon dioxide goes up, the 2 different VOCs, the nitrogen dioxide, ethanol, carbon monoxide, and ammonia. What's that?
You can see it all.
Yes, yeah, you can visually see it. But what I determined is when I started training this, not one of these would give me the results I needed. It ended up being a collection of like 5 or 6. Now there are some overlap. Like your 2 VOCs kind of follow similar patterns along with your ethanol. So I could throw away like 2 of these and get, right, there's overlap with machine, like a lot of times in machine learning, overlap is bad because it's just kind of wasted data. It just takes up processing power. So there's all these techniques you can do to be like, which of these are more important? And then let's use like the top 5 or the top 6 of these to get there. And then once it got to red, I would visually look at it and smell it like, okay, I think that's burnt. And I hit a button. And I did this like dozens of times to get a bunch of data like this. And I trained a neural network. It ended up being a fairly simple neural network, but it was a window over time. Like it would take like 2 or 3 seconds of a window of like the 5 or 6 different gas sensors, and it would go through this neural network, and it would give me a prediction of number of seconds until burnt. And the reason I can't give you, there's 2 reasons I can't give you a live demo of that, and one is the big one is it was trained in that house at the time. I've tried it in different environments, and it doesn't. Yeah, so somebody when I gave this talk at SuperCon, when I gave that talk at SuperCon not last year but the year before. Somebody was like, oh, just put it in an enclosure. Good, it's what we do with like 3D printers. And so that would be one way to solve it, is just train it inside of like an acrylic enclosure, and then it would like, you know, I could control the environment in that. So that's one way to do it, but I also like cannibalize some of it for parts. And it's like, I've got some of the boards here if you want to look at them, but it's the WIO terminal and those gas sensors. It's just like moving it is a kind of a pain. So that's what I did, and here's where I tore the toaster apart and soldered it into the system where like you would push the lever down and it would trigger the on, and so it would like found where the LED would come on, and I could sense that, so I just like put that right into the like ran a wire into the WIO terminal and said, oh, I know now it's on, so I can run my AI because I've triggered that the toast is in, and then another one that would actually control, I think the yellow one would control the actual release button. Right, there's a button that should be like cancel, and so I could pop it using the cancel button. So what I do is I turn the timer up to max. I'd let this program run, and then when it felt like it was 30 or 40 seconds before the toast being burnt, it would just pop it up. It would cancel the process early, and so you can see number of predicted seconds until burnt. Right, I've got the knob on max. I put the toast in, and it would give me number of seconds until burnt. I do have a video of it working. I don't know if I'm going to be able to. Yeah, I got my sound off, which is probably for the best, but I've got this video up on YouTube. Check it out. So we put the toast in, and it says toasting, right? It picked up that I pushed the lever in, and it gives me a number of seconds, and it kind of bounces around until it gets closer. 42 seconds is exactly, well, I mean, it should be 42, and yeah, that's what I got. It was like AI created toast based on smell. And it worked. And so the impressive thing was I trained it on like one type of toast, or like 2 different types of toast. I even like, I started throwing everything at it, like frozen bagels. I never trained it on frozen bagels. It handled them no problem. It gave me like perfectly toasted bagels. Now it didn't know to push the like bagel button, but you know, that being said, it was actually well toasted. It was perfectly toasted. I was very excited with this.
That's one question.
With that,
So with bread, people usually have preferences, right? Because some people like it less toasted, some people like it very toasted. That would just mean changing the duration where it triggers, like instead
Yes.
of 30 seconds, it will be 50 seconds. If you want less toasted or 20 seconds. it
Well,
will-
obviously this is right. No, I'm just kidding. No, my
For somebody else.
no, I know. No, like my girlfriend actually likes it like almost bread, and I'm like
Yeah.
golden, and then I know people who want like black
Brown.
bread, right? No, you're absolutely right. So yeah, you could say like for her it would be like 55 seconds before it burnt, and for me it'd be like 40 seconds, and for somebody who wants it really done, it'd be like 0 seconds, and it comes out like crispy. So yeah, you could dial it there, but you're no longer relying on a timer, thankfully. You're
Yeah,
now.
would you need to train the model again, or do you think just changing that time?
I think you could just change the threshold. So like the knob would no longer change a timer. The knob would now change like a doneness level.
Yeah.
And then it would just be based on like time until done, because or time until burn. Uh-oh. Oh, we got a question. Now you have to add in so people can say with preference, almost like, yeah.
Exactly.
That's exactly it. I just saw that. Thank you. That's perfect.
Nice one, man.
Exactly. Yeah, that would be the next thing. Okay, so now let's get to the next slide here. So, fun story. This was a problem that was solved back in the 30s, and it does a much better job of it than any sort of AI I could possibly throw. I don't know why they don't make toasters like this. I'm guessing like certainly the patent has to be near expired at this point, or somebody. I think it's Sunbeam who made this
Yes, I've
toaster.
heard of this.
Yes.
Yeah. My brother-in-law was banging on about it years ago.
Yeah.
Yeah.
It's this YouTube video that came out a couple of years ago.
Uh-huh.
Why is this good?
So it uses a bimetallic strip down here. So here's the actual patent. You can look it up. It was filed in 1935. It was approved in 1940, and you can find this toaster if you go to like antique shops. You can probably find this toaster that was built in like 1942 or something. It uses a bimetallic strip, just like those old thermostats with like the little like needles on it. So same thing. It measures temperature, but it's really close. So you push
This
on the
sideways?
side. Yeah, this is side. So toast would come in here, and it's near the side of the toast, so it's very close without touching your toast. Now, this means that like only certain like cuts of toast work, right? You can see the slots are really narrow. It's not going to work very well with like bagels or anything. But it would just measure basically the surface temperature of the toast. And turns out that was like almost perfect every single. So I'm just like, dang it. But which is fine, right? Sometimes this is a hilarious example of sometimes you don't need AI. The simpler thing will get you there. Although you could probably make a joke that this is like mechanical AI because it's solving goals in the world, right? It fits that definition. Yeah. That would call this mechanical AI, just a bimetallic strip. It's basically a thermostat, just like a toaster version of a thermostat. And then we of course have the new complicated AI. So this is the toaster oven you can buy. This company was just bought by GE, I think. I can't quite remember. If you look up June Oven, you can see who they were purchased by. And they actually have a camera that looks down on whatever you're toasting or baking. And the idea is it can identify toast, it can identify cookies or anything else you might bake. And it uses like object detection to like look at the coloration and determine when something is done. I still like mine better because it's going by smell. Because I feel like for AI, like machine learning these days, like vision is everything. Everyone just throws vision at everything. And I'm like, there's gotta be a cheaper, better way than vision. Because vision can be a pain in the butt. But so why would I do this? Because it was fun. Like, honestly, it was a fun project to learn about AI. Could I get something to like do something interesting with smell? Right. That was the idea. So I mentioned earlier, I want to like be able to just construct some arbitrary robot, push a button, have it just learn to walk. Lots of companies are working on this, right? We got Boston Dynamics, Disney made that really cool bipedal robot recently. People are working like self-flying drones, and ETH Zurich did this bot. You can look up this video. It's a bot that can like it's a quadruped, but it's got these wheels and it can like just stand up and balance itself. It's all using like reinforcement learning to do this. It's super wild where this is going. So just a brief overview of reinforcement learning. So I started with this tower. It's just like a kit you can buy that does a self-balancing. The idea is you put, classical control theory stuff at it. You can like, oh, let's get the pendulum to balance, right? Super common if you've ever done control theory class, this is like your final project they'll make you do. So the idea is you have some sort of interpreter that could be vision, that could be, or in my case, I was using quadrature encoder to figure out where the thing was positioned, as well as looking at the position of the stepper motor around of the tower. All of that's fed into an agent, including a reward based on, hey, you're doing a good job, or you're not doing a good job. Are you winning that chess game? Or you're not winning that chess game? That kind of thing. That agent then figures out based on the observations and the rewards it's learned, its update from that, and it performs the action, and the loop continues as the agent continually updates. So that's the machine learning side of it. I wanted to see if I can make this into Edge AI, where I would train it on my computer. Right, I hooked it up to an Arduino. It learned to do the swing up. What I discovered is I have a latency problem, even with just USB. I had a latency problem where I couldn't control it fast enough to actually get it to balance. I've got some ideas on how to get it there. That might be paperwork. Here's hoping. But once it was fully trained, I could take the agent, which was really just like a 2-layer dense neural network, and move it to the ESP32. And that's all I did is like, okay, now it runs and it can perform the swing up. And I've got a video of it doing the swing up. I mean, like this is really not that interesting because it's like, yes, this is a solved problem by like, you can get classical control theory to do this, right? But it's like interesting. It's like an AI learned to do this on its own. That's why I think it's fun. It learned to do the swing up on its own. I wanted to get it to fully balance, but I couldn't at the time because of a latency issue. No, stop. Next slide. So how do we fix this? Sorry, there are a number of problems we have with doing this. So if you've got the like robot that wants to like move and I want it to train to walk overnight, there's a number of problems. First of all, like the latency that I said, right? That round trip thing is a problem. I could put the robot on my desk. I could say go, and like the robot might walk off the table. Well, who's going to pick it up and put it back in its original place, or it gets caught in a corner, right? I got to watch it and it takes days to train these things, days or weeks of just constantly letting it go. Like these reinforcement learning algorithms are not very efficient. It takes a long time. And it took it hours, like half a day just to train it to do the swing up. And that's like real simple in the reinforcement learning world. And so you have a reset problem. How do I reset this? And I only have one. These robots are expensive. So this is where we get into virtual simulation. So these companies like NVIDIA, they put out this thing called Omniverse. Y'all like familiar with Unity. A lot of video games are made in Unity. Can we set up a robot in there or a reinforcement learning thing and have it train over time? And not only do I solve the reset problem, because I just say, hey, reset the environment, goes back to where it was. I can now just clone this and run thousands of copies at the same time and have it learn different things. So the ability to parallelize them is really, really nice. Now, even if I like mimic my robot in these, there's going to always be a problem of when I bring it to the real world, it's always not quite the same. That's just the case. So you need to have some sort of way to update your model in the real world once it's trained. But hopefully you can get the vast majority, 99% of the way there with these virtual simulations, and then be able to get it back to the real world and say, okay, you just learned to walk. Brilliant to go.
Is that like transfer learning when you take like
yeah
model and then you kind of slightly adapt it?
Yeah, it would probably be a version of transfer learning,
right.
Where you've got it mostly trained on one thing. You're like, I need you to tweak a little bit in the real world. Yeah, you use transfer learning for that. Exactly. So I've got a friend, Dimitri Maslow, who did stuff for C. He's now at Edge Impulse, but he got one of the Biddles. He never got to work in the real world, but he was able to get them running in NVIDIA Omniverse. So you can see them kind of learning to hop along. They never got the full stride, but he wasn't able to solve the hardware problem. And so I solved the hardware problem. So he's like, when I showed him my talk, that was when I gave it this SuperCon last year. He was like, oh, you've inspired me. I'm pulling my Biddle out of my garage and I'm going to go like tinker with it. Because he got the NVIDIA, like the Omniverse virtual world. And I'm like, oh, now we have a 2-man a Boston Dynamics team going, right? So eventually I do want to get myself a Biddle and like, can I get it trained? I want to see the work he did and see if I can get it to train to learn how to walk. Like that would be so cool. Stop with the things. We have like 10 minutes left. So some other projects I'll burn through really quickly. This was out of Carnegie Mellon. In one of their hackathons, professor worked with some students. They made a magic wand. I think it was an ESP32. They made a 3D printed little wand case for it. And they set up this backdrop you could see behind them here. And so you push a button, you do the magical, I'm gonna like Stelliano's gesture or whatever it was, right? And so it wasn't word-based, it was just gesture-based. And so you do it, and the LEDs in the target behind them would start to light up towards the other person. The other person would have to do the counter spell to that spell to block it, or they would like lose a hit point or something. And so they created this like virtual but real game by using Edge ML to do this. Which like this is super cool. I think this is a really neat game. It'd be like a fun demo or a thing to like show off at a hackathon. Smart HVAC systems. This thing I was talking about, somebody had like this model mock-up setup where you could do people counting to figure out how much do I need to adjust HVAC, your like heating and AC in a room. B counting, one of the guys that one of our lead machine learning people at Edge Impulse, he's like an amateur beekeeper. He has these, he has a couple of bee houses. And he wanted to see how many bees come in and out every day. So he wanted to count the number of bees and monitor it over the course of the year or over their lifetime. And so he developed this model that's now in Edge Impulse called FOMO, because it could run on those really small devices. Not really good at finding like bounding boxes, but really good at finding like centroids of objects. And so it was great for things like object counting or object tracking across, but not saying like is it close or near to, or close or far from a camera, or like how big is it? It's really good for like, hey, there's 40 bees in this picture. Good for some industrial cases, especially when we want to run it on cheap hardware.
So does FOMO count other things other than bees?
Yeah, I mean, yeah, you can train it for whatever. Use
Okay, you have to train it.
Yeah,
your own.
Exactly. So we've got these demos we'll take to like trade show, counts M&Ms going across a conveyor belt, that kind of thing. What other fun thing? Posture monitoring. This person on hackathon, or excuse me, Hackster.io, was using some ML to like he was using like muscle sensors or like right to like track his like posture to make sure he's like engaging the right muscles. But there's a million ways you could do this with like posture detection or pose detection from like you could have like a camera pointed at you from like, hey, are you in good posture or not? But this is another idea for like solving a problem of like helping me get better posture. I met this person at hackathon because he won like 4th place in one of the Hackaday prizes. So he had these acrylic walls that he made into this like inverted pyramid. And you would drop an item in, and based on the sound it would make, it would determine the type of material it was. So is it aluminum? Is it plastic? Right? Which is a cool way to do it, because a lot of people would try to tackle this with cameras.
Yeah.
Which is so hard, because like aluminum things can be in any freaking shape you can imagine.
Yeah.
So he's doing it with sound, which I thought was a really cool, really slick take on this. Let's see, what other fun projects? Come on. Plant health monitoring. This person I think used like color sensing, which I don't think you need full AI for. But I could easily see like, hey, doing object detection on leaves, and then based on the like an individual leaf, look for like spots or look for anomalies or look for, right, you can identify different things. So plant health monitoring, big use cases in agriculture. Can you identify this plant versus this, which means can I have robots doing weeding for me, that kind of thing. This person made a dog bark stopper, which I thought was funny because I had the same idea to do with my dog because he loves to bark. Right, you leave the room. Shut up, dogs. And so it would identify a bark using sound, and this one like used his voice to be like, shh, quiet, sit, right? Like, and it like he had the video like it worked the first time, and the dog was like, "What is this?" Right? Like, what is this? I don't understand. And I'm like, my dog would do the same thing, and then eventually realize it means nothing, and then just bark right over it. So it worked once, at least for the video. This person identifies snoring. Oops, what I did. This person would identify if you were snoring, and like you could like wear this pouch or like put it in your pocket while you slept, and it would vibrate to wake you up. Be like, hey, stop snoring. So hopefully that gives you some good project ideas. If you're curious where to go, I gave a workshop. If I'm able to do another, apparently there's like a CU hackathon that happens. I don't know if y'all put it on, if they're going to do one this year. But yeah, I talked to Ellen. What's that?
There's one this week in Atlas.
Oh, okay.
But I think there's another one, which is the cross CU one.
This the big CU one. Okay. But yeah, I could do that workshop again at some point. Just fitting in my schedule can be tough, but there's lots of stuff out there. The TinyML cookbook by Gianmarco is actually really good. It gives you a broad overview of different ways to do TinyML, both from like a low code Edge Impulse perspective, or how do you do the like hardcore TensorFlow thing yourself, or even dives into like let's take scikit-learn, which is a Python package. We're going to train a model, usually using like classical ML stuff like decision trees or SVMs. And let's convert that to C code and run it on a microcontroller. So it gives you a smattering of those things and then a few projects you can go through. So it's actually a really good book to get you started. I've got my course on Coursera. It's completely free. Coursera will nag you to say, hey, make sure you like pay us money to get a certificate. You don't have to do that. The course is free. It's just Coursera trying to make money. And then there's the Tiny Machine Learning on edX. That's by the Harvard professor. And I think Pete Morgan makes a guest appearance, and there's another DevRel guy from Google. They did this course together. That's like the much longer version where they like really dive into like TensorFlow. Mine's like high level with like Edge Impulse. You can do this in like you can do like mine in like a week and get an idea of like training your own models with like Edge Impulse and deploying them.
So
wow.
Yeah. So if I did a course or did some FOMO and got a model working for this, is it easy then to transfer that onto my laptop or my phone for it to a browser to also work?
In theory, yeah. So most of our stuff from Edge Impulse, I'm going to just talk from Edge Impulse.
Sure, yeah.
The big thing we give you is a C++ library. It's got the trained model, all the weights in there, and it's like wrapped up in this nice C++ model, and you're like, here you go, C++. Call these functions, and now you can do inference, which is amazing for most embedded systems, because now I'm just like link it into my library, I call the functions, and boom, I'm running it on like all the embedded systems. Can you do that on your phone? Yes. But if you're like doing it on like an iPhone, you have to like translate like C++ to Swift, or right? Or
what about in the browser?
So we have this, so C++ in the browser, probably not. But we can also give you WebAssembly, which is kind of this like black box binary that's kind of got the same stuff. And so you can like hook into that and call stuff from there. Okay. We don't have a lot of docs on it, but it is possible with like WebAssembly. So then you can like get that WebAssembly, which is just like a binary like WASM. It gets pushed to the browser, the client, and then you can run stuff on top of that. So you can do like JavaScript calling my WebAssembly hooks. That's possible. You can also use us. You can get a TensorFlow light model from us, and then there's lots of ways to import that to other things. But it doesn't have any of the front end stuff. So like for camera stuff, that's easy. That's fine. Just use the TensorFlow. It's great for like Python, and you can probably translate it to something that Swift understands and your browser, because Google will make that work for you. But if you try to do like your magic wand, or you try to do like voice, there's a lot of pre-processing that needs to happen that takes your voice and gets things like basically think creating a spectrogram. And then we do, yeah, you do like FFT. For voice, they usually do Mel frequency septal coefficients, which is like you get an FFT, you basically get like a spectrogram with your FFTs, and then you like do these like filters on them based on like the frequencies, and then you take that and you do the discrete cosine transform. So you get like an idea of the shape of it, and then you do machine learning. You do your machine learning on that to like classification. It's a lot of work to get to the point where the ML does a really good job with it. So if you just get the TensorFlow light model, it's not that front end. It's only the back end of like the machine learning classification system. So if you're trying to do that, that gets a little more difficult, because now you have to like write your own MFCCs, or you have to go into like, if you're using Python, you can use not scikit-learn. What's the other big like scientific processing one that I can't remember the name of right now? But like they have an MFCC thing you can just call, right. But then you have to like match theirs versus ours. Does that make sense?
Yeah.
So it's a little wonky and a little tricky. In theory, yes, especially for vision stuff, you're just like, oh, make sure the image is this many pixels by this many pixels and send it off to the TensorFlow light. You're good.
SciPy.
SciPy. Yes, thank you, SciPy. I don't know why I could not remember that. That escaped my mind, but that's it, SciPy. Because I actually think we're using SciPy on the back end to do the training.
Right. Okay.
Yeah. Hopefully that helps. Hopefully it gives you some ideas of like fun projects to make.
Yeah. I mean, I'd love to make something that works across these. I have this working, but not this working. But then I was wondering, it might be easier to make something that works for this first, and then that's easier to translate to a more powerful processor here.
Probably. What did you like? Is that iPhone?
Yeah.
So did you train it with like the Apple system?
No, it's just off the shelf kind of
YOLO.
Yeah, it's basically YOLO.
Oh, got it. Yeah, if you're talking about YOLO, Oh, yeah,
Then
YOLO's
FOMO, and then I
Yeah.
could maybe get FOMO running in this.
That should be possible, yeah, either WebAssembly, if you're gonna do it in a browser, or you can do, get the TensorFlow Lite model.
Yeah.
And I can't give you 100% guarantee, but I'm willing to bet a lot of money on that you can get a TensorFlow Lite model into whatever the Apple ML system is, that I can't remember the name of right now, because I don't tinker with that, so.
Yeah, sure, yeah. That's great, thank you.
Yeah, you're welcome.
Apple does not make it easy to tinker anyway.
What's that?
Apple doesn't make it easy to tinker anyway.
No, like, it's kind of one of those, like, if you're in their ecosystem, like, and you understand their ecosystem, it's easy, but they don't like to make it to translate
Yeah.
across. They really don't. So, are they kicking us out?
There's supposed to be another meeting here, but yeah, I mean, if anybody has questions
Yeah,
online or here,
hopefully this was helpful. Did y'all get some out of it?
Oh, yeah,
Did it give you some ideas for like fun projects?
yes, yeah.